All right, let's talk about one of the most important ideas for anyone trying to make AI work in the real world, the AI data flywheel. This is the secret engine that keeps a smart AI, well, smart.
And really, this is the big question, isn't it? You spend all this time and money building an amazing AI model. It works perfectly on day one. But what about a few months down the road, or a year? How do you stop it from getting dumber over time?
So here's our game plan for today. We're going to start with the challenges of scaling AI, then we'll get right into what a data flywheel actually is. We'll look at the nuts and bolts of how it works, why it's such a game changer, and finally, how you can actually put one to work.
Okay, first up, let's really understand the problem. Why is it so darn hard to keep AI applications working great once you scale them up? Think of it like friction, something that's constantly trying to slow down your AI's progress.
And this friction shows up in a few really painful ways. First, you've got model drift. That's when your AI just slowly gets less accurate because the world changes and it doesn't. Then there are the costs, which just seem to spiral out of control. And finally, your AI starts giving stale, outdated answers because it's lost touch with what's happening right now.
So, what's the answer to all this friction? Well, it's this really cool concept called the data flywheel. This is the engine that drives non-stop automatic improvement for your AI.
At its core, the AI data flywheel is basically a self-improving loop. See, every single time a person interacts with your AI, new data gets created. The flywheel is the system that grabs that data, all the questions, the answers, the feedback, and uses it to automatically make the AI model better. It's a learning loop that never stops.
And this kicks off an incredibly powerful cycle. A better, smarter model gives your users a better experience. That better experience leads to them giving you better, more useful data, and that better data, well, you use it to build an even smarter model. It just keeps getting better and better, spinning faster with each turn.
So how does this thing actually spin? What does it look like in practice? Well, it's not just magic. It's a pretty well-defined six-step process that turns raw data into a constantly improving AI.
Let's walk through these 6 steps. It all starts with data processing. You got to clean up your data. Next is customization, where you teach a general model all your specific lingo and knowledge. Step 3 is evaluation, to make sure the model is actually any good. Then you put up guardrails for safety. After that, you deploy it, often using something like RAG so it has fresh info. And finally, this is the most important part, refinement, where you take all that user feedback and feed it right back into your data to start the whole cycle over again.
You can really break this whole thing down into 2 big phases. Steps 1 to 3 are all about building the model. You're cleaning data, you're teaching it, and you're testing it. Then, steps 4 to 6 are about running the model out in the wild. You're making it safe, you're plugging it into live information, and you're capturing all that awesome feedback to make your data even stronger. Okay, so we've seen the how, but let's get to the so what. Why should you even bother with all this? This is where we go from a cool technical idea to something that has a real tangible impact on your business.
The benefits here are huge. You end up building applications that are way more cost-effective. You can create super personalized experiences because the AI is learning from real people. And that stuff, it leads directly to things like better sales and higher productivity. Plus, you get to use smaller, more efficient models, which solves that whole model drift problem we started with.
Let's make this real with an actual example. Take AT&T. They had a classic problem. They wanted to use AI agents for customer service, but they were getting hit with those exact issues we talked about: model drift and just insane computational costs.
So they put a data flywheel-style platform into motion. And the potential impact on their inference costs, that's the cost to run the model every time a customer asks a question, was just, well, take a look at this number.
Yeah, a 98% potential savings on inference. That is absolutely massive. And it's possible because the flywheel lets you take all the knowledge from a huge, expensive model and distill it down into a much smaller, cheaper one that's just as accurate for everyday tasks. It's the definition of working smarter, not harder.
Okay, so you're sold on the idea. How do you actually get one of these flywheels spinning in your own company? Well, it's not a one-person job. It takes the right people in the right roles with the right tools.
Making this thing work is a total team sport. You've got your data engineers who curate all the data. The AI developers use that data to build the models. Your MLOps teams get them deployed safely. And this is critical. You need a human in the loop to check the AI's work, making sure only the good stuff gets fed back into the system.
Now, trying to coordinate all of that manually would be a nightmare. It's just not going to happen at scale. That's why having an end-to-end platform is absolutely essential. It's what automates the whole cycle and connects all the dots so you're not drowning in manual work.
A platform like NVIDIA Nemo is a perfect example of this. It's got a whole suite of tools that map directly to those 6 steps we talked about. There's a curator for data, a customizer for fine-tuning, an evaluator for testing, plus tools for guardrails and a retriever to connect to live data. See, it's the kind of tech that really makes the flywheel spin.
So as we wrap this up, it really all boils down to one simple question. All of your data, every customer interaction, every new document, it's talking. It's telling you how to get better. The real question is, have you built a system that lets your AI actually listen? Because that is the key to keeping it smart, not just for today, but for every day after.